now we can start with the seminar. We have also some English-speaking people listening, so the seminar will be in English. And Olev Märtens will talk about his studies and the institutions with which he has been working together. So, floor is yours.
Yes, okay. Thank you all very much, and I'm very much surprised, positively, or impressed that so many people listening and following this event today. And yes, I'm really happy to have this presentation. And I'm currently in Tallinn, Mustamäe, and most of you, I guess, are in Taravere and Tartu. And greetings, of course, to everyone. And my name is Olev Märtens, and also I need to make a clear disclaimer that this work we are talking today, this is done at Eesti Keskkonnaagentuur or Estonian Environment Agency solely, and I was working on private base or as hobby project, and this specific work is not connected to my other jobs. For example, my main job as today is at TalTech or Tallinn University of Technology, Department of Electronics. This is clear disclaimer that this is work of this Keskkonnaagentuur. And talk is about the evaluation of heat islands in Estonian cities 2014 to 2019. And one study was initiated by Environment Agency of Estonia. And I was the main author and doer doing this report and work behind this. It was from summer 2019. Most work I made in Christmas time, previous Christmas time. And then somewhere in March or April, it was finally launched by Environment Agency. And also, result of this work, I shared some link in the chat. You see the report itself is in Estonian language and available also from the Environment Agency website. But for any case, I put it also here below this link, this Estonian language report. And also there are more photos and more plots, a little bit compared with today's presentation, and maybe more heat maps and temperature maps of the cities compared with the slides. And here below you see on the first slide, you see also that there are some links in media, Postimees have been, and also there are some information on Keskkonnaagentuur or Environment Agency, links and links and links further. And also one result of this work was the report in Estonian language, but another result was some set of shape files of these urban heat islands and possible highlands or what we did. And these map layers are available at this Maamet, this our land board, this geoportal or something like this. So it's possible. And I have not checked myself, but people checked and confirmed that this map layer seems to work in reality. Okay, and about the IEEE membership, and I shall say later 2 words. Then about Estonian Environment Agency, maybe you have more cooperations or different views or experiences, but of course on the website there is some information. So they are belonging to somehow related or under the Environmental Ministry of Estonia, and they are dealing with overall monitoring. And also from some time ago they have incorporated or merged or joined these our weather stations at Harku and Taravere, Tartu, and so on and so on. They are also now merged to this Keskkonnaamet. And also, I don't know if it is finalized or not yet, but I have heard, noticed there have been some plans that every airport typically probably has some kind of weather station, measurement station, and so far this has to be belonging to airports. But now I heard that this environment agency will take over, or has taken over, or I don't know, but so they are going wider and wider. And also, sorry, coming back to the first slide, the co-authors of this report were two people from environmental agency, Keskkonnaagentuur, Riina Berg and Ekaterina Susanikina. Ekaterina has PhD degree, also from TalTech. She's working at agency, and she provided very important guidelines, starting points, and also, if you look to the report, there are some original photos of the land, which are extracted by her. And Riina Berg is working not in the main house of the agency, but she's working, Riina provided all these temperature measurements from the Harku and all other weather stations, all these time series. So they were provided by Riina, and all these people, and many more people were participating in this development process. So Riina and Ekaterina were important persons from agency. Then about me, yes, so I'm born in 1960, Tallinn, Estonia. All my diplomas and studies are here in Tallinn. Secondary school number 21, engineering diploma of electronics, 1983, PhD from 2000, and so on, everything from this Mustamäe house. And also, I have been working my whole life, more or less, on development on electronic instrumentation. And of course, already when I was a student, I was making some precise measurement converters, including analog to digital in 1980s for our studies in the university. But also, what is important for me, I was working at has been this factory, RED, radio building factory from 1930s, but as a factory developing and producing also different instrumentation of voltmeters, ohm meters, resistances in the background, calibrators and so on. Best in the Soviet Union this time. And there was also a separate design office or konstrueringsbyrå, Tallinna Radioelektroonika konstrueringsbyrå. And I was working there on Estonia Puiestė 5. And I was working there as research and development engineer on very precise AC, alternative current instrumentation. And our department was well known as patenting and inventive people, who is head of the department, Tom Pungas, at this time, very famous. And from some time, I am series inventor, mainly in the instrumentation. And also one side effect of this instrumentation was our people here in TPI this time, or TalTech nowadays, had some cooperation with Turavere, who is Uno Weisman, with some instrumentation for optical measurements and some even for the Salute space labs. And at the end, I a little bit participated and contributed with one 20-bit or 6 decimal digits AD converter for the studies. And so if you see Uno, of course, best wishes and greetings still. We remember this important time. And also, yes, I've been working with different things, like impedance, electrical resistance, and what can be used in the measurement of not only bio and metals and composites, but also for soils and grounds. And also the last sentence on this slide is that the only formal training in the field of remote sensing is one small workshop from 2014, what took place in Tallinn Factory House. Maybe people remember, maybe not. Anu, Reinald, Mait Lang were these times the names where we made some quite simple exercises with these cookies or these things, and which was also inspiring. And if you have any questions, of course, you can ask in the chat or just take a microphone at this moment and switch it back. So about me. Then, of course, I am promoting this IEEE organization, Institute of Electrical and Engineering, Institute of Electrical and Electronic Engineers. And of course, it's over time we have this pop-off named Society of Radio and Electronics, and Postman even was way of communication. You get a letter from the post office. But yes, now it's this organization. Initially started as an American organization in 1884. Later merged with Institute of Radio Engineers, which started in 1912. And at least who started the Estonian radio industry. Maybe you have heard the main names of Red Factory, for example, were Hans Roland Burke and Freddie Albright. At least Hans Roland Burke was member of this IEEE in 1930s. And also have quite active section, Estonian section. You can look at IEEE.ee, our local contact people. And personally, I have been member of IEEE for 20 plus years, and specifically with Instrumentation and Measurement Society, IMS, and we have been recognized and noticed in several ways and awards. For a shorter time, I have been member of IEEE Signal Processing Society, SPS. Also, image processing is behind this. And of course, there are many aspects in signal processing and image processing. But one aspect, we're quite famous in Estonia together with people of mathematics, like Gert Tamberg in our house, Taltech house, yes, we have other people from Tallinna University. And our slogan is SAMTA, Sampling, Theory and Applications. We have contacts with world famous signal and image processing people. And one aspect is if we deal with analog signals, real world is analog, real images, real temperature maps, real whatever surfaces controls are continuous. And we need to sample in digital case in time, frequency, space, and whatever domains. And how to interpolate, extrapolate, compress, and so on and so on. And for example, that non-uniform sampling is better than uniformly sampling leads, and so on. So this is important also in our background and also of today's presentation background, if to develop further to think about these aspects. And also third, just for this 2020 years, I am trying this membership of this GRSS, Society of IEEE Geoscience and Remote Sensing Society. And as August 2020, I checked, it was confirmed that there is one person more in Estonia, in the Estonian section, belonging to this society, and totally not known name for me. And also, this person did not respond to my email, so it's anonymous. So maybe there is some space in membership. Also for the students, there are student branches in Tartu and Tallinn. Okay, so this was about IEEE. Then organization. Then now coming back to this specific project or study, the idea was very simple: to download available Landsat 8 satellite images and then to find the possible heat wave periods from archives, also including the ground measurements from our weather stations, and then to calculate or estimate this temperature. And of course, from satellite images, we are getting not actual air temperature, but so-called land surface temperature is a product. Possible and then to make analysis for larger cities. And in this study, it was people from environmental agency decided Tallinn, Tartu, Pärnu, Narva, Kohtla-Järve, Viljandi, Rakvere, and to make the maps and some of these shape files and layers for these maps. And of course, there was some discussion of the possible satellite images, Sentinel or Landsat or something else, but finally we decided Landsat because of better resolution in the space, in the ground. But unfortunately, the problem is that Landsat, they have some period of they are going around the globe every 16 or 17 days only. So this is a very long period. And further, and even worse, or not so good, that this can be cloudy day than this next time. And of course, Sentinel could be better by shorter time period. And so on. So there is a lot of space of discussion. And for future development, I believe a great idea could be fusion of different satellite images or combining together. Okay, but finally we decided for answer 8 after some discussion and hesitation. Actually, I already started and I made some preliminary software to download and analyze and map. So also, I think it was Sentinel-3 maybe. But okay, then I dropped it. Then some terms in my very free translation back to English from Estonian. So about one term is urban heat islands, or was it Kuumasaared or Soojasaared in Estonian already? Forgetting they were very angry people with me. Yes, probably, yes. And so urban heat islands, and typically it's explained as temperature is above the surrounding. There is some background temperature and something is above significantly. But how many degrees, it's typically not defined. Is it 3 or 5 or 10 degrees? And also what is the surrounding or background, how this is taken. Yes, Landsat 8, this is America's satellite of US Geological Survey in cooperation with NASA. So alternative is ESA and Sentinel, of course. And all these images are freely available, freely downloadable. This has been also my very own idea, only open source, only free data to be used. And I did not look into, of course, Environment Agency offered their own connections, databases, and access opportunities. And but I don't believe very much that there could be anything much more accessible compared with this freely downloadable data. And then one question was to define the heat waves as possible candidate time periods in which to look these possible heat maps and these heat waves and urban heat islands. And in Estonia, it seems they have agreed that heat waves, they are danger level and extreme danger level. And for first case, it's that over 3 days, in every day at least 27 degrees peak value, or extremely dangerous 30 degrees. Or if to take daily average or mean value, then it's in the first case, if it's more than 20, or extremely bad if it's more than 25 degrees of Celsius. This is a local criteria of Environmental Agency. Then some references. Of course, there are many papers available, and also at least a first paper is very similar work where what made in Skopje, Macedonia, where urban heat island analysis was made just with Landsat 8 satellite data. And also important is this reference number 2 by our local Estonian people, Sagris and Sepp, with whom I am personally not familiar yet, but this is important starting point, of course, and about somehow similar work has already been done as described in this IEEE Geoscience and Remote Sensing Society letters. Yes, and there are, yes, this is important to mention. And also what is important, Environmental Agency, very much people reminded me that there is some famous Kotti report. I don't know, are you people hearing now familiar with this Kotti? Well, this was just one keyword, and so it was requested to be added, and I had no time to look very detailedly into this report, but it's mentioned and addressed clearly. Also, this urban heat islands in this work. But honestly to say, I had some problems to find public access or public link to this document. So I was using the privately sent by agency copy of this report. And of course, there are many other references and much work has been done, and different satellites has been used, and whatever MODIS data or Sentinel data, and in China and whatever. And now, a few words about this work of Sagris and Sepp and this from this society letters. And they are mainly addressing, it seems, 2014 was extremely hot summer in Estonia, and not only in Estonia, over Europe. And this is one important reference, summer. Anyway, and also what is important to mention, that of course, land surface temperature is estimated, we all guess, from infrared band. This is temperature. But also in this paper it's mentioned that in previous algorithms that were used, bands 10 and 11, 2 infrared bands available of Landsat. But at some time it was dropped, and band 11 was eliminated from the scheme because there is some calibration uncertainty matters. So old algorithm was 2 infrared bands, new algorithm is with only band number 10. And so what we did, exactly so. And in this paper there are some maps of Tallinn, for example, 2014. And I don't know what exactly, how this was made by this author this time. It's July 9th, July 25th. Okay. This is important reference. And also shortly the slide how we calculate, and it's quite straightforward. In this first reference, for example, there is some very simple calculation scheme. We take simply the numbers, intensivity values from bands 4 and 5 to calculate some NDVI estimation. Band 4 and 5, you see here, red and near infrared. And we also take band 10 directly. This is thermal infrared, first channel, and you see here the wavelengths and resolution. And then there is some calculation scheme, and I simply took it and calculated for every pixel in these images. And of course, first we needed to cut out, because that image is covering a huge area, and we take only Tallinn or only Tartu, and then we calculated for every pixel. And as the work was very limited in time and money and whatever, then different questions of accuracy and resolution and precision and whatever occurs. and one of them is the accuracy in the space, or in the spatial 2 and 3-dimensional spaces. And as you see, bands 4 and 5 has 30 meters, 1 pixel, and infrared band has 100 meters. And of course, probably we guess that all together it will be 100-meter grid. But from other side, technically, all these images are, by my impression, oversampled, or the final grid of all these bands, they are all in the same grid. I guess is a 30-meter grid. So still we process mathematically and in the signal processing sense, everything in 30-meter grid. And also, as you know, in signal processing and whatever is the effective number of bits and effective number of pixels and so on, the things are more sophisticated. Of course, by default, we guess that it is this 30 or 100-meter grid. But sometimes it's possible to interpolate, extrapolate, especially as signal processing people say, if the original signal is band limited, this temperature is not changing very very fast. If it's changing slowly, we can interpolate as higher and so on. So it's still, next question could be to understand better accuracy in the temperature scale of our estimations and in this grid size. Okay, then Rina Berg from from the weather station site provided for all regions some time series, and I plotted them up. I made some hard language script from 25 to 31 degrees, and we see for every year and every surrounding of every city and the interest. And we took the nearest weather station. We see the time series, and we see and also marked satellites where they are flying over with less than 15% clouds or less than 40%. So we have a very rough estimation where we can have both high temperature and satellite in this day. And so we can prepare next selection of these places and times where we do it. And so we plotted out all these time series versus available satellite imaging. Of course, we can go more precise. We can do also to look specifically above Tallinn or Tartu or Pärnu. Are the pixels cloudy or not? But in this case, we had some rough estimations, and we took data we can exclude not good images and which are cloudy. And so that was one step. We had a look in combination, temperature, waves, and available satellites. 2014, 2019, and something between. And then I made some Python software, Python scripts, which just extract and calculate by this scheme and show. And in every case, I made it in 2 or even 3 versions. One output was simply temperature scale. You see here from 20 to 40 degrees of Celsius, and it's simply, you see the temperature in every city. And also on the right, you see here is I make it like this segmented and found the borders to have shape files and to see the borders of these possible heat islands. And here we took 30, 35, and 40 degrees as thresholds. And so I plotted these. So basically I made a Python script which generated left and right image and also the shape file for this portal. And in the link I shared in the beginning, in the seminar, there are all of these images available, and also in the report, which is also there a copy. And in some places you see here the okay, I see one question is, I'll come to back it later, yes, about these roofs. And in some places where it's white and dark blue, you see these are clouds, clearly. These are clouds. And of course, this could be taken off automatically because every pixel in this raw data are labeled. But this is yet not done. We see it anyway already, it's clouds. And so on. So we have some images. And also, one question was about this something are very heat, and it was for me very new understanding that it's not necessarily very heat, very warm house, but this can be some field, some soil, dark soil, or even peat soil or turvas can be, and the same. And also in Narva, this is not house, this is some, how is English, this set the bassin, some bassin or pool, where this mud of this water cleaning, this utility or something is put into the surface or something. And also near Tallinn, I think there was very, if I come back to Tallinn, I think it was here, some places. Here there is some, yes, in Tallinn here. These are not houses, as I suggested myself with my stupid head. And also in Narva, these are not houses. Yes. And coming back to this Narva houses, but from other side, it's interesting to know for the people that is it a good place to live nearby some hot places, or maybe it's good in the winter time. There is some natural, biological and other processes that you can enjoy without hard heating. Okay, so these maps were generated. Also, some problem was first I took it automatically because the task was to make for Pärnu, Tallinn, so on. But the problem is if I take these formal map layers, shape files from our official Maa-amet, this geoportal, every this municipally has local names inside and local limits. And Pärnu initially was very huge, you know, Pärnu city was new, this regional administrative borders, literally half of Estonia, and to put it here is not reasonable. From other side, Viimsi and Rae are outside of Tallinn city. So if by default I took local, by default this peak values, maximum min max values for every this to cut out this, but then in some cases I made them wider or smaller manually for every city case. Okay, and so basically what I did some Python code, nothing else. And example of how to download, connect to this Landsat Explorer databases, and upper side to define the region, to define the start and end date. You can give optionally max cloud cover, and you can get list of all possible scenes or image sets. And later you can easily download. And they are quite huge files, so it takes some time and some internet connection. So somewhere, I'm not showing the whole Python code, but of course, especially in the processing, whatever this, to cut out these interested regions and to make this, whatever this conversion calculation of LSD and surface temperature from raw pixel values. And also one important question is to remap, as I mentioned here, because globe, see, to say in popular words, see the round globe and our Estonian official map, this EPSG 3301, is flat map. We have to reproject. In my case, I made it point by point, pixel by pixel, from original to our Estonian map. And it was actually quite slow mathematically and in the software, and so I made some tricks to speed it up, the projection. And as you see, several libraries and toolboxes were used in this work, and maybe some of them were not optimal, but anyway, I could make it all working, and maybe some of them finally were not used, but at least these were tried in one or another stage. Of course, somewhere is Panda and GeoPanda, and somewhere is Python itself, which is NumPy, and so on. And also I tried this, I like OpenCV libraries, but in this case, there was no sense finally. And also here you see some fragment of calculation of LST from this raw data from bands 4, 5, and 10. So this is simple mathematics, and Python is very good because one in the code we have this whatever some variable rate 10b. This is actually a matrix, and the result will be again a matrix, two-dimensional, and we can very easily make calculations. So it's actually few lines of Python code to calculate this LST. And yes, so this was a talk. And also to emphasize here that actually as overall encouragement to everybody, so this remote sensing making applications is not rocket science. You can make, even so such not experienced person like me can in short time learn and make such scripts getting these results. And also I am not familiar with Python very much, so it was actually yes much fun to learn Python with help of Google to find appropriate functions and tools. So much fun, and I recommend to everybody. So this is actually very easy to start with Python and remote sensing. And also one comment, I am very sorry about this, that at the time and everything was limited. Actually, of course, if you look onto these heat maps, just they seem to be quite reasonable, the numbers of the temperature, but the next work could be to compare, for example, with these measured temperatures in the weather stations. What are the discrepancies, differences, and possible correlations? And also, so one thing is this, in the temperature domain, possible accuracy, precision, repeatability, uncertainty, and so on. And other aspect is also accuracy, resolution, whatever in the space or in this spatial domain in the land, how many meters or kilometers is actually our accuracy or resolution. And this could be very interesting and to be further investigated. And also one my question is for myself more than myself, is it something to be written in some magazine or journal, or to be added, maybe some instrumentation or accuracy estimation, for example, aspects. Okay, and of course, special thanks to Environmental Agency, and also there were many people from Environmental Ministry around the table while we were discussing our project. Not only Rina and Ekaterina, but also Maris Arro, Agnes Aroveli, and Svetlana from Ministry. And Svetlana Pudova was actually the main person from this agency, Svetlana, who worked with me. And below there are my contacts in this context if you like to whatever discuss now or later. And you are very welcome also outside of this meeting to contact and whatever you have ideas or interests or questions. And all ideas and comments are very welcome. From the business side, technical side, programming side, and so on. So thank you very much. And I'm of course waiting for the questions, comments. And about the first question is from Matthias. Yes, this is also a very good question, that what could be these extremely rare places? Are they houses and roofs, as we guess, or is it some soil, or is it some different roof materials and things? And this is really interesting to look into. And really, I cannot comment what is below this, behind this. This is the next question. And maybe also some machine learning and artificial intelligence can be used. Also from visible light, we can estimate, maybe is it from metal roof, or is it some stone roof, or whatever, or is it house at all? Maybe we can have some classifier, and then maybe for every class of roof we can have some correction factors. Who knows? Who knows? Yes. Very good question. Yes. Maybe more questions, comments.
I guess I will stop recording so that for the questions time we can have a slower session of questions without recording.